How do our bodies create electricity? The short answer is chemical energy. To understand why, let's look at the long answer. What most people think of as electricity is simply the movement of an electrical charge. To move, and as a result use the potential charge, we need an energy source. Some of the most common are hydroelectric, nuclear, solar and wind. Technological advances have allowed us to harness these sources, giving us wonders like computers and vibrating smartphones. The energy created by chemicals is due to the reactions of the atoms and molecules present. All of the elements we take in our bodies, like oxygen, sodium, potassium, and calcium, have a specific electrical charge, meaning they have a specific number of electrons, protons, and neutrons. Those specific charges, whether positive or negative, react to the charges of adjacent molecules. This reaction is what creates the energy needed to create electricity. When we eat or drink, the large molecules within our food get broken down by digestion, creating similar molecules. Those smaller molecules can be used by our cells to do work. This process is called cellular respiration. All of those molecules and elements in our bodies have the potential to create electrical impulses. Arguably, the most commonly mentioned electrical current within our bodies is the heart rhythm. Hearts contain, within them, a grouping of cells known as your sinoatrial node, or SA node. These cells within the SA node, sometimes called the pacemaker of the heart, contain electrolytes both inside and outside of the cells. The most common electrolytes within the body are sodium, potassium, calcium, magnesium, phosphorus, and chloride. Sodium and calcium generally reside outside of the SA node cells. Potassium generally lies within them. The cell membrane acts as a barrier between these electrolytes. Pressure within the bloodstream allows sodium to enter the cell, causing potassium to leave it. Less potassium leaves the cell than sodium entering it. The result is a continually growing positive charge. When the charge reaches a certain point, calcium channels in the cell membrane open up and allow for calcium to enter. This makes the interior of the cell extremely positive compared to the outside of the cell, known as an action potential. Once that potential reaches a certain point, it has enough power to discharge down the nerves of the heart. This electricity causes the muscles to contract and your heart to beat. Electrolytes crossing cell membranes, creating electrical discharges, is one of the countless ways the body uses the food we eat to create energy and power to do work. This is why the food content we eat is classified in calories, a calorie being a unit of energy. As technology advances, medical science will continue to unravel all the mysteries surrounding how the chemical reactions within our bodies maintain our daily lives and create our own bioelectricity.